All right. Hello, everyone. Thanks for joining in. Do let me know if I'm not audible or there's any trouble with my video or anything that I'm sharing here. I have a full screen here, so I may not be able to see if you're raising your hand or if you have a question. Feel free to stop me anytime, and we can take up your question then after that. I see that Ankita is in here, Ankita Kumari, Shreya Shankar, Sudhanshu Arora, Professor Nilesh Narayan. There is one with the phone number 894. I don't have the name here. It'll be nice if you can just put your name so that we can speak to you. Muhammad Arif, sorry. Rajan, Abhiranjan, Anish, Harshita, and NK, Ayansh Puri, PK is Prabhat, I think, Ankita. All right, fine. So okay, all right. So hello everyone, thanks for joining in. My name is 𝘗𝘊𝘗𝘴, and thanks for taking this time and joining the session. We're going to have a very interactive session today. Something that our goal here is going to be to understand AI, not only in terms of the theory aspect of it, but also how to apply it, how to use it. And we will have hands-on exercises which will expose you to and which will make you a lot more comfortable with how to with AI, generative AI. Okay, this is a boot camp, and the goal here is to have these generative AI artifacts programs run on your machine, and you actually execute it. So what we will do is, this is a 3-hour boot camp. In the first hour, we will get a baseline of where each one of us stands. Each one of us maybe have a different level of exposure to AI. So it's always better to understand what is the baseline rather than making an assumption that you may know certain things and take it from there. So we'll have that discussion, and then we will get straight into installations. We will work through certain softwares that you'll need to have on your machine. And once you have that, then we will get on to some hands-on exercises so that you get a good feel of how generative AI can be applied and how it works. All right. So welcome to Generative AI Bootcamp. And thanks AIforAll global team for organizing this. It's a very, very nice initiative and a very helpful initiative, which will bridge the gap between theory and how actually we apply AI. All right, so this is me. My name is 𝘗𝘊𝘗𝘴. I'm a senior technical architect. I primarily work in the banking, so I deal with payments, anything that's related to payments. I work on that, be it payments, compliance, fraud management, fund transfer, international transfers, all these payment related, credit cards, debit cards, all these items. And I've also been very focused on applying generative AI into multiple areas of banking and beyond banking also. And I've got a good understanding based on my experience on systems that we have implemented traditionally without AI all these years, and the newer systems that we are working towards applying AI and seeing the difference of how what it brings to the table in terms of not only the solution but also the entire changed architecture in terms of what it actually means to you, in terms of effort that has been put, in terms of the time to market, and in terms of the accuracy of the solution also. So all these aspects of an application all have been redefined with the help of generative AI. You will also understand that a lot of it is good, and also there are some trade-offs which you have to be very, very aware of, because those could land you in trouble also. And that's the reason why having a hands-on exercise becomes very, very important for us, rather than just saying that we have understood the theory and we seem to know how this works. All right. So in terms of that, this is going to be a very good exercise. I will just open up this link here. So these are my Medium publications. So I've been very active in publishing, working out solutions, and also publishing them so that the learning grows. All these publications that I hear are public. They are available for everyone. This is the link, 𝘗𝘭𝘆𝘐.medium.com. You can go to it. You can pick up any of these case studies. So all these are actual case studies, and all the challenges that we have faced in implementing these, and what is the approach, a practical approach that was taken to solve these problems. So this is what has been documented. There is also a detailed architecture. There are trade-offs listed between various approaches taken. And also many of these publications also has a video which where I explain on how the solution is implemented. It has the details on the implementation, the code, all that, and you're free and you're welcome to go through these. Some of these very interesting ones are this one related to credit card fraud detection. We already have a traditional solution which does fraud detection. This one here takes the AI approach, how to detect fraud on live transactions, and also it explains what is the difference between the two approaches, and how the newer approach brings a lot of benefit to you in terms of maintenance and in terms of also flexibility of the solution. There are many others here. This one here talks about PII. PII basically means personally identifiable information, where in banks and in a finance environment, it becomes very, very important that PII is protected. Otherwise, there is huge penalties that the bank has to face, and also you lose public credibility then. So it's actually a massive exercise if you have to maintain PII in a traditional system. And when you use generative AI for that same thing, it becomes a much more seamless exercise and a much more flexible exercise. So that's what this case study explains here. There are many others here which are also platform related, where we have productivity tools like you write unit test cases, you write certain tools which help your development environment. So those tools are also explained here, how those custom tools were made. This one here talks about multiple vector databases. So you will realize that depending on your solution, a particular database may work for you, and for another solution, some other database may work well for you. So it's a very very intricate exercise to have all these databases put together and then keep switching between them. This one here, which is a switch automation, vector DB switch automation, what it does is it actually switches on the fly to whichever database you choose to connect to. Okay, so this is a platform-oriented case study, and this is also available for your reference. This one is a very interesting one. This one relates to we had a lot of this was a more practical one also. We had a lot of interviews that were happening in the company, and given that we were busy with our own schedules, we weren't able to spend that much time on interviewing. So I created this automation where the AI talks to the interviewee, and once he talks the answer, those answers get recorded as voice. From voice, they get transcripted into text. This is all AI does. And once it gets transcribed into text, it is fed into an AI engine, which does the evaluation of the response. And then we can provide criteria on how to evaluate what is the pass percentage. And once that pass percentage reached, only those candidates are then selected for the next stage, for the face-to-face round. Thus, we save a lot of time on filtering out candidates who are really not genuine or really not competent enough. So all these case studies deal with many practical aspects. You can go through these. Okay. Next, we will go through the baseline, and then we will take the next step forward. I would really like to know the room here. We have about 8 to 10 people. I'm assuming each one of you is from a different, diverse background, diverse experience level. It'll be nice if y'all can introduce yourself so that we get to know where we stand, and then accordingly we can move forward with the exercise. If you're okay, just open up your mics and you all can just let me know what you do and what's your level of exposure to AI and what have you worked on in AI so far. Yep, if that's okay with you all, let's go ahead with that. Does anyone want to introduce or talk about AI experience?
Perhaps good to do that with a nomination, one name nomination, and then we make a round table.
So, can I start first?
Yes.
Post that will, yeah. So, hi everyone, I'm 𝗔𝗴𝗄𝗏. My overall experience is approximately 15 years and working in a BFSI domain industry, and my company name is Experian. And my main profile is the project management, and I'm working as the delivery manager here. This is my brief intro, and I will nominate Sudhanshu Arora.
Yeah, thanks, Rajan.
Yeah, myself Sudhanshu Arora, and I'm working in Nokia for the past 20 years. And I have joined this to learn about the new technology. And I'm working as a telecom engineer and pre-sales engineer right now.
Okay. If you could also tell me about your exposure to AI. Are you just starting on AI or have you already implemented AI? That would be very helpful also.
Yeah, in the AI field, I am known to about all the machine learning models. And regarding the AI part, yes, LLM models are known to me. So I have an exposure to AI.
Okay, that's good then. All right. Shall we just move forward?
Yes, please.
Sudhanshu, you please nominate someone.
Or we could just have a session where just people just let me know, like who's totally new to AI, haven't yet got a chance to work on anything substantial yet. Is there anyone who's completely new to AI?
Hi, so 𝗷𝘂𝘃, can I introduce myself?
Yes, sure. Thanks, Arif.
Yeah, so hi, I am Arif and I am second year student in pursuing BBA, Bachelor's in Business Administration from Vaishali Institute. And I use AI, all the LLMs for my daily work, like normal brainstorming about feeding data and asking better opinions, is it worthy or not? And all the like daily life decisions, I use it. And sometimes for writing also, like for LinkedIn post as well. So I don't know much about the technical aspect, how it runs in the backward, but I know some basic, like we have provided the LLM so much data that it regenerates and give us output according to that. So yeah, and the well we prompt, the well we give context, and then the anchor like act as a XYZ, so it will give us more better response. So those things I know, but I am not much aware about technical aspect, how it runs in the background. So that's something I'm new about it. And
Got it. Yeah.
Yeah, and
Got
I
it.
nominate 𝘗𝘁𝗨 for next. Thank you.
Yes. Yeah. All right. So pretty much I'm getting a feeling that you'll have certain degree of exposure to AI. Maybe the level of technical exposure probably is varying, but certainly each one of us knows what AI is and what is the capability of AI. And we are here to explore on that front more on how AI can actually be practically applied on the ground, right? So let's do that. And feel free to stop me if you all still want to talk about yourself, your experience. Feel free to chip in, okay? We'll take the next step, and then you'll let me know whenever you need me to halt or have any questions further. All right. So here I want to ask you one question before we move forward. Just a second. Just check. Yeah, I'm going to ask you a question before we move forward. In a traditional system, each one of you would have had a chance to work on traditional systems, right? We know that a traditional system looks something like this. You have a client, like some channel sending a request. You have someone. You have your program that will be taking that request, sending it to the server, and then you have some database at the end of it, right? That will do the data related work. So you have the 3-tier architecture generally: the front end, the middle tier, and the back end, right? If I ask you, how do you envision an AI system, a equivalent AI system? What is going to be your view? How do you envision an AI system to be? Does it also have these kind of 3-tier system, or is it totally different? So let's flip the question. If I ask you, if I ask you, there is this traditional system here, okay, which is a 3-tier system. I want you to convert the system into an AI system, AI capable system. Okay, what will you do? What will you change in this flow here? It's a very straightforward system. There is a database. There's some kind of rules engine which does the processing logic and all that. And there is this Python which takes a request and sends it. So almost like a middle tier and database and some kind of rules engine. And these are your tables and all schemas of the tables and all that stuff. If I ask you to change this to an AI system, what is it that you're going to do? Which component are you going to change in here to make it an AI system?
Maybe the rules engine part.
Yeah, that makes sense. Yes. Anything else that comes to your mind? What is the easiest way to convert this into an AI system? How about this?
Rule engine can be changed to AI machine learning algorithms.
Absolutely. Yes, that makes sense. Okay. Now, what is the easiest way to convert that traditional system into an AI system? Okay. How about you straight away introduce OpenAI, Grok, and Anthropic to it? What will happen? Will you get an AI system, AI capable system? You will, right? Absolutely, you will, because Grok, Anthropic, OpenAI, or all these are very capable AI systems wherein you can send your request and it will do the AI processing for you, and you'll get a response. Very, very strong systems there, right? So that's the easiest way for you to convert this traditional architecture into an AI architecture. You just have to send a request, have a subscription, make the necessary payments, and then you will be able to get a system here, right? But what do you see is the problem here? Do you see any kind of challenge here? Why do you think this box is black in color? The reason it is black in color is because when you interact with systems like this, OpenAI, Grok and all that, they do a lot of processing for you and give you ready-made answers. But what happens is that it's a black box. You really don't know what is happening in there, right? And for us, we are not here to just make a call to an AI system and get a response. The goal here for our session here is to understand what exactly is happening behind these systems and how can we leverage that capability into our applications. So if it had to be just making a call to the system, really frankly, this kind of bootcamp would really not be necessary. And that's the reason I want you to understand what actually happens in this. So when you open up this black box, and that's what we're going to do in this session, when you open up this black box, this is what you get. Okay, this whole black box transforms into this system here, which is an AI, generative AI system. What do you see is the main components here? From compared to here, what do you see are the main components here that we have introduced into this AI system to make this an AI system? Do you see any difference between the first architecture and this one here? So first thing we see is that you see there's a rules engine here. What we have done is that instead of the rules engine, we have introduced something called LLM models. Okay, what does a rules engine do? A rules engine has a set of rules, and that's a logic, right? If something happens, then do this. If something else happens, do this. It's a set of rules, set of logic. That rules engine is now replaced with an LLM model, large language model. And this large language model is the one that will have all the knowledge, all the understanding, and when you ask it a question, it'll be able to respond to you. Okay, that's the reason we have we have replaced the rules engine with an LLM model. All right. What else do you see is a difference here? You see there is a Python here, which is basically like a server side. Okay, some kind of application server that constantly listens to requests and then takes a request and sends it to the backend system. We have replaced that with something called Ullama LLM server. Okay, so this is Spring Boot here, but doesn't matter, Spring Boot Python. In your traditional system, you generally have a application server or a web server, right? That takes in the request and then it sends it to your backend systems. So instead of using a server like Tomcat, JBoss, which are regular type of servers, we have simply changed that with a server called Ullama, which is an LLM server. Okay, and why did we change that to an LLM server? Why could we not use a regular JBoss or a web application or a WebLogic server? Any thoughts on that? The reason is that your WebLogic, your JBoss servers do not have the capability to talk to an LLM model. They can talk to a rules engine, they can talk to a database, a regular database, but they don't have the capability to talk to an LLM. And also, you will realize that the type of database that we're using here is called vector database. Generally, you would have come across databases which are RDBMS, MongoDB, those kind of databases. NoSQL type of databases, but here the type of database that we're using is a very specialized database, and this is called a vector database. That's another big difference between the traditional architecture and the new architecture. If you use a regular database like RDBMS, there is one main capability that you will not be getting, which is required for an AI system, and that capability is called semantic understanding. Okay, so what happens is that when you save data into your database, in your regular database, RDBMS, Oracle, MySQL, the data gets saved in a certain structure. Okay, but when you save data into vector DB, there is a very special capability. There is a very special capability that you get hold of, and that capability is called semantic understanding, which means whatever data that you're storing into your database, the system is able to understand the meaning of that word, In none of your other databases, this capability is possible. They will only understand that this is a word, this is a particular element, and that element is related to some other element. Like customer is an element, and customer is related to, say, loan, and there is a relationship between them. But typically, it will not understand what is meant by a customer. But when you put that kind of information into a vector DB, not only it understands these kind of terms, but it also understands the surrounding meaning of these two words. So for example, when I put something like Germany, into my vector database, what happens is that it not only saves Germany into that, but also it saves the surrounding meaning of Germany. Things like Germany is a country. Germany is located in Europe. Germany has so and so neighboring countries. All this kind of information about Germany is stored in the vector database, and the way it is stored is also a very, very specialized way. It is not stored as like, certain information is not stored like as additional information. There's a process that happens where the text that you save gets converted into an encoded number, and that number that gets encoded is a very, very specialized number, and that's what gives it the ability to understand what Germany is. And that is the capability that makes this particular architecture an AI architecture, and it makes it much, much more capable than this particular traditional system. Okay, that is the aspect that makes your application an artificially intelligent application, and which is not possible in your traditional application. Do you have any questions so far of these components that we talked of? These are the core components of an artificial intelligent system. With these components, everything else can be built, be it a simple application, complex application, an application that can do simple things, multiple things, apply to different domains. A lot of these things can be done, and these are the main core components that are required for that. Do you have any questions related to this, or do you want to know more about these? Just give me a second. Okay, so this is what an artificial intelligence system is. There is something else called embeddings model. What actually converts that particular word that we just talked of into the meaning, and that is called the embedding model. It's an algorithm that has been provided. Whenever something gets inserted into your LLM or into your vector DB, there is an algorithm that gets associated with it. That is the algorithm that converts these words into certain numbers, and these numbers are the ones that are special numbers which have the meaning around it. All right. So so have you understood now that these are the components that are actually required into your AI system? Do you all have any further questions that we need to talk about, or you're okay? Can I just get a feel from you all? I'm not able to see the screen.
I have a question. Is the vector database completely different from the normal database?
Yes. I couldn't tell who was asking that question.
Yeah, I am 𝘍𝘺𝘀.
Sudhanshu. Yeah. It is very, very different from a regular database, and I'll explain why it's different. See, the core functionality of a database is the same, that it will store data, right? And it can store volumes of data into a database. Up to that point, everything's the same. You can do this in a Oracle database, like an RDBMS database. You can do it in a vector database also. The big difference that comes in these two databases is that how this data is stored. You very well know that when you store data into a regular database like Oracle, it gets stored in the form of B+ trees. Okay, and the data is structured in a particular way where structuring is very, very important. Like you need to have a certain structures created, normalized structures created, and then mappings created between various structures and all that stuff, right? The structuring is very important. But in a vector database, that is the part that becomes completely different. What happens is that when you store something into your vector database, it does not get stored as like tables or mappings between tables and all that. All the text that you're saving in your vector database gets converted into a number, and that number is it's called embeddings model, and that is how the number is the one that actually stores information about that particular entity that you're storing in. So in your regular database, when you store something, it only stores that element. But when you store something in your vector database or in your LLM model, it stores not only that element, but also a lot of attributes about that particular element, just like the way I explained to you what happens when you store Germany in it. And I'll show you one more thing. When you save data into your vector database or into your LLM model, this is the format it gets saved into. This is called a embeddings model. This is called an embeddings array. And all your data gets encoded into this particular format. Okay, and these numbers that you're seeing here are very, very special numbers. When I save a word or when I save a line, a statement into my vector database, each of that gets converted into these numbers. And these numbers not only understand what that individual word means, but also they understand when you save something like a statement like this, I went to the bank, it also understands the contextual meaning of it. Okay, so here when I say bank, what does it mean to you? What does it mean to you? What is a bank?
I got your point. So basically, it's a vector embedding method, and that database and that is stored as a database embedding in the format of an embedding, right?
Yes, there are two main factors here. One is that it stored all the attributes around it, and also it stores the contextual meaning about it. So bank could mean multiple things to different people. A bank could mean that it's a financial bank. A bank could also mean that it's a river bank. A bank could also mean it's a blood bank, right? It depends on the context that you're talking about. So
Okay.
that kind of information, that kind of intelligence gets encoded into these numbers and gets saved into your vector database. That is a capability none of your regular databases have, and that's what makes a big difference between your vector database and your regular database, and that's what gives immense power to your artificial intelligence application. There are things that you can do with an artificial intelligence application which you cannot do with a traditional application, and the reason for that is this. The reason for that is this, that the way this data gets saved and the way the attributes around that particular entity gets saved. Okay, and that's the most important part of your artificial intelligence application.
Thanks.
All right. So what we'll do now is that keep asking your question. What we'll do now is that we will straight away jump into now that we know what an artificial intelligence application is. How about we actually experience it? How about we start doing some hands-on and try to set up this system on your machines and then see what it feels like. Right. For that, what we will do is that I will give you a resource, a GitHub resource. I want you all to go there. You can check out. You can download whatever you need to do. And there is a procedure there. I will open it up here and show it to you. Yeah, this is the GitHub resource. I will put it up here in the chat. Can you all check your access? It's a public GitHub, so all of you should have access to this. Can you all just confirm that? Okay, Raghuveer says yes. So what I want you to do is you can follow as I do it. And what we'll do is we will get started with the steps to set this up in your machines. Okay, this might take a while, so it's good that we start off sooner so that we have enough time to have this set up on your machine, and also have enough time to do these exercises hands-on. All right. So just tell me, I want you all to tell me as you all go through it, like, whether you all can do it, not do it, and all that. So feel free to open your mics, feel free to talk. Okay, and then we'll work through this together. All right, because this is a boot camp, it'll help everyone if you all are more proactive, if you all are more participative, and you all can tell me how this is going with you all. All right. So once you'll have access to this, there is a folder here called machine setup. Can you all check that out and tell me whether you all can go to it or not up to this point? And I will open up the Windows machine setup. Okay. I don't think I'll be able to see any of your chats or something once that screen is open. So do let me know. Do let me know where you all are. You all can talk and tell me, because I won't be able to follow through with the chats. Okay. I have a full screen here. So are you all on this on the setup now? On this page? Machine setup Windows?
Yes.
Okay, fine. So what this page does is that there is a corresponding Mac page also, but let's look at Windows here. The architecture that we just saw, that is this 4 components: LLM models, LLM server, vector database, and this embeddings model, which is an algorithm. This is exactly what we are going to do now in terms of setup. Okay, so if you look at here, whatever we sequentially explained just now is what we are going to be installing on your machine. Okay, we're going to make your machine an AI capable machine so that you can execute these things on your machine. All right, so very first step here is that for now you can ignore the Docker setup. Can you all just tell me who does not have a Docker setup at present on your machine? And it's okay not to have it. I just want to know.
No, I don't have.
Who does not have? Say that again. Someone said something.
Yeah, it's Val. Me neither. I don't have.
Okay, you don't have. Anyone else who doesn't have Docker setup?
No, I don't have.
Say the name, please, because I'm not able to.
Yeah, hi, this is
Unless I
Rakesh.
switch back, I can't tell who it is. Yeah. Okay, at least 2 people don't have, right? I mean, I heard that at least 2 people don't have it. Okay, what we'll do is for now, we will just 3 don't have it. Okay, for now, we will ignore that part, the Docker part. We will go to the components that we can actually do without Docker. Okay, so you see, when we looked at this architecture diagram, there were 3 important components that we talked of. One is the LLM models, and there is something called LLM server. We will start with the LLM server. Just like in your traditional application, you'll have an application server, a web server like Tomcat or JBoss or WebLogic. Same way here also we have a server, LLM server, and that LLM server is called Ollama. Ollama is just one of the LLM servers. It's one of the more reliable LLM servers, and that's what we're going to be putting up on your machines. Okay, so this is the instruction here. Once you all are here, now that you all have access to this GitHub resource, if you just follow these steps here, you will be able to set this up on your machine. Okay, so what we can do hence now on is that I already have this installed on my machine. I want you all to install on your machine, and then we can take it forward. All right, so if it's okay with any of you, you all can open up your you can share your screen, and then we can do it on your screen so that others also can see and follow through. Is that all right? Anyone who's
Yes.
willing to just share your screen, and you can
Yes.
do the instruction on your screen.
Can I share my screen?
Yeah, absolutely, yes. Tell me if you're having trouble, because I don't know if I have to give you permission or something, but let me know if sharing is possible or not. Are you able to share?
Yes, now I'm able to share. Just give me 1 minute. Okay, I think someone else is sharing the screen, so I'm not able to share.
Maybe it's then I have to stop my sharing. 1 minute.
Okay.
Where does that? One participant, multiple participant can share simultaneously. Let's try that now. Now see if you can.
Let me try just 1 minute.
So is this Rajan? Rajan, you are the one who's sharing. Okay, great.
Yes, I'm Rajan.
Yeah.
Okay. So what is the next step?
Yeah, I'm not able to. I'm not able to see your screen.
I already.
I'll do a stop sharing. Okay. Now I think it's much more clearer. This is your screen.
Yes.
Well, let's just follow these instructions. You have to just go to this site, which is ulama.download, and just download it for Windows. Yeah, I'm assuming your machine is Windows, so we go for Windows. Okay, everyone just follow, look at this thing, and if you have trouble, just let me know. Yeah, so this things takes a little while because these are heavy installations, but we will go through it and we will work through these steps. Okay. Anyone else who's trying this out at this point? Can you all tell me if how is it going for you all?
Yeah, I'm downloading.
Okay.
I tried to download it on the Mac, but it doesn't.
There is a Mac option. It doesn't work for you. It's this one here. Well.
Yeah.
That's the one. This should work for you, Mac.
Yeah. Okay. Okay. But if I click on it, it doesn't. Code view is read only. Okay. Do I need to copy the web page into GitHub?
No. You just have to open up this page.
Okay.
On the Rajan, can you just open up the GitHub?
Oh, I have it downloaded on Mac. I have it.
Yeah, that's the one you need to follow for Mac.
Okay,
I don't have GitHub actually.
Okay, no problem. So Val has got the right page for Mac. Val, that's a page you'll follow. All the Mac instructions are there.
Yeah.
Okay, fine. So Rajan, I believe it's still downloading for you. Yeah.
It's downloaded. Yeah, it's downloaded now.
Nice. Now let's look at the next step in the instructions, and then we'll follow through that.
Okay, so
on the GitHub page, the instructions are there. Can you open that up?
Where I will find this one?
Yeah, the GitHub link is in your chat.
Okay.
In the Zoom chat, the GitHub link is there. Yes. Open up that machine setup directory. And the Windows, yes. Okay. And if you can just zoom your screen, it's not very clear. Control P. Okay. It's still not visible.
Now is it okay?
Yes. Now it is better. So let's go to the next step now, the install part. 2B. Go ahead and double click and install it from that execution. Yeah.
I have it here on the downloads. Double click on it and then.
Yes. Who else has Mac here? Is Ankur on the call?
I have Mac. I can also help. Vijay.
Okay, great. Have you also started these instructions? Have you downloaded Ollama
I've
for the
done
Mac?
that in past, so not now. I do have it.
Fine. So can you just help and guide Val? Well, now that you have it downloaded on your machine, what's the next step? She just has to double click on it so that it installs on Mac?
Yes, precisely. It's very simple. It's just download and double click like any application you install Val. So double click and bring it to app.
So where can I find it? That's my problem now. I'm completely.
So if you go to Chrome on the top right side where download button comes, there you will see that it is downloaded. If you click that show in Finder, you will find the location.
So Val can also go on that download folder, I think.
Can be different for different.
Okay.
Yeah.
But do you see on Chrome on top the download, the place where you have all the downloads?
No. And you can hit the install here so that your installation starts.
Okay.
Maybe you can share your screen, Val, if you like. I can guide you. Or Rajan, you can start, Rajan. You can
go ahead,
start
Rajan.
this
Install.
install.
Okay, I click on install.
Yeah, good. This will take some time, so just allow it.
Oh, so it's on download. So now I know where to go. Okay.
Yeah. In case of Mac, it will not do all this. You just double click and it will be there very quickly.
Okay. So basically you find it in applications, right?
Right now it must be in download, but once you double click, it will go to application once it is installed.
Yeah. Okay.
Currently, if you have downloaded, it will be in download folder.
Okay.
Gauri, Shriyanshu, Almajan, are you all okay? Have you all tried it out? If anyone is having trouble, just let me know.
Are you able to find Val?
Yeah, I'm still trying.
Do you see this annotation, the annotation that I'm making on the screen, this green thing? That's where where you will find,
Okay.
That's the place where you have to look in your Chrome browser. You used Chrome, right? So
no, I use Safari.
Yeah, so Safari also must be having something like this on top.
Okay.
If you click there, you will see whether this thing has downloaded, right?
Yes.
And then if you see Ollama there in the list,
yes,
you just double click it, it will open.
Okay.
And then it will say that install. And then
Okay. All right. So Rajan, we can move to the next step. Ollama is installed.
Yes.
Okay. And I see that icon showing up there.
Yes.
Okay. Now go to step 2C, ensure that output. Okay. Anyways, it didn't give you any error. So it completed the installation. Yes. Ollama list is what we need to do. Correct, Anish. Just open up a command console now, command prompt. CMD is good. And And you can paste that command in there, which is there in the next instruction, 𝗚 list. Yeah.
𝗚 list.
Yeah, go for it. Enter.
Enter.
All right. So this is the output you're seeing. Right now it's blank. That's perfectly fine.
Yes.
Okay, so you got 𝗚 done. So of the three components, that one is checked out for you, Rajan. Okay, we can move to the next step now.
This one.
Yeah, you got an output. You got an output, right?
Okay. Yes, I got output.
We're good there. Yeah. Is everyone else on the same stage? Is anyone else having trouble with this step?
No, I'm good.
Okay, great. Well, how about others? Anish already has it, he said. And anyone else is having trouble? I'm assuming everyone's gone through. Do let me know if you all have trouble, okay? We'll move to the next step. Now what we will do is, from the architecture diagram again, there's a second component in there, which is called LLM model, which means all the rules engine, all the knowledge that is required is there in the LLM model. Your LLM server has the ability to talk to this, and that's why we need to give it this LLM model. That's what we will now install it. Okay, so go ahead, Rajan. Open up a command console again, new one, and we will run this command there.
This one.
Open up a new one. No, open up a new one.
Okay.
Yeah. So what we are doing here is an LLM model. Just to give you a background on this, LLM model stands for large language model. Okay. Just like your rules engine in a traditional application where you put a lot of information in that software, you put a lot of rules there, you put a lot of logic in there, right? All that stuff gets replaced with something called LLM model. The speciality of an LLM model, which your rules engine does not have normally, usually does not have, is that your LLM model has the knowledge, has the understanding, and has the information of this entire, everything in this entire world. Every single thing in this entire world. Okay. And from that very statement itself, you can understand how powerful this LLM is. Now imagine having this kind of software on your machine where you can ask any question and you can get answers, accurate answers to anything. You can ask it, what is the capital of Germany? It will give you the correct answer. You can ask it, how many planets are there in this universe? It will give the correct answers. You can ask it, what is the population of India? And it will give you the correct answers. What is the molecular formula of alcohol? It will give you the correct answers. Okay. So imagine having something like this within your reach, which can give you all the information. That is the capability you're getting with an LLM model, which you cannot get with a traditional application. All right, that's what we are installing now, the LLM model here. And the specific model that we have chosen, there are hundreds of models available, but the specific model that we have chosen, yeah, go for it, Rajan, hit enter. This will take some time to install. The specific model that we have chosen is called Llama 3. Okay, there is another one called DeepSeek R1. There is many others called Phi3 and many other. You can choose any of them. We just took Llama 3 because it's one of the more popular ones and more reliable ones. Okay, this Llama 3 has size of around 4.7 GB, so it'll occupy about 5 GB on your machine. Okay, that's why you need to have enough space on your hard disk. Much more than 5 GB, of course. All right, so that's a step we are doing here, and this will take some time, so we will allow it to complete. All right.
So one question I have, that is free of cost, or that is a paid service, something like?
Everything that we are doing here right now are open source. That means it's free of cost.
So,
Okay.
Once we have to install the Llama, then we have to install the Llama, right?
Llama 3, yes.
And what is the role of Llama 3? It's a middleware or what?
Yeah. So what happens is that, like I showed you in that architecture diagram,
yeah.
You have an application server in your traditional application, right? Like WebLogic and all, which takes in the request and then sends it back to your database or any other components that you have in your middle tier.
So
it has the ability to interact with any of the components. So that way, your Llama 𝗏 is like that application server. It will take any request that is coming from outside. Now, based on the request, you may want to interact with a vector database. You may want to interact with the LLM model. An LLM model is an artifact, is a software which has information about this entire world. Okay, so if you want to ask any question, get any information about anything in this world, you can ask this LLM model. Okay, and that's why we need Llama 3. Llama 3 is a 5 gigabyte software, and which has information about everything in this world. That's why Llama 3.
So first layer is Ollama. Then we have the Llama layer, which can interact with the LLM, or which can interact with the embedding.
Your LLM server, which is Llama, is interacting with the Llama 3, which is the LLM itself.
Okay.
Okay. And within the LLM, inside the LLM, there is something called embeddings. So your Llama 3 is internally interacting with your embeddings.
Okay. Thanks.
Okay. And I just want to show you the architecture diagram again. Yeah.
Which I have one question. Why did you choose Ollama and not ChatGPT, for example?
Yeah, I'll explain that. So what happens, Val, is that when we interact with ChatGPT, we have an interface that comes up. It's a chat interface that comes up, which is on your web browser. And when you put a question in there and hit submit, what actually happens is that question that you put goes to something called a LLM server. And that LLM server is Ollama, or an equivalent of it. So what we have done here is that we have removed that layer now. We want to get deeper into AI.
Okay.
Right? We want to get deeper into it. So we are already one level deeper now. So we are already, so whenever you interact with that chat GPT, it goes to an LLM server, and we are at that stage now.
Okay, thank you.
Okay. Yeah. And while we do this, Rajan, can you just open up a website on your browser, ollama.com. Ollama.com. Yes. OAA. Yes.
Is that also an idea to take a group picture maybe in 10 minutes when we can ask everyone to come on camera, and then we can take a picture?
Yeah, absolutely. Yes, yeah. While we wait for this installation to happen, we can definitely do that.
Yes.
There's a request here. If you all can come on the camera and we can take one picture of all of us.
Yeah, in 10 minutes. So let's give everyone some time, and in 10 minutes we'll do.
Yeah, let's do that. Okay, so here I want to show you this very interesting thing here. Okay, Rajan has opened up something called ollama.com. Okay, and Rajan, click on models there. You see models on the left hand side?
Yes, I got that. This one, I think.
No, just click on the models on the left hand side top.
Wait.
Left hand side top, models. My left hand side. That's it. Keep going to the left corner. Keep going. There you go. Models. Yeah. Okay. I want to show you something interesting here. Type Llama 3.
Where? Search model?
In the search bar. Yes. Type Llama 3. LLAMA. Yeah. You see, the question that was asked is about Llama 3, right? See, there are many models that are available. How do you know which models are available, what to choose, how? Because I knew about Llama 3, I just told you let's download Llama 3, and I have good experience with it. But let's say you choose to find more information. Which models do you want? There is Llama 3 available here. When you just put Llama 3, you get tons of information of everything that's available. Even in Llama 3, there are many versions available. You can just read through it and pick and choose whichever version you want. All this is open source, all this is free, and all this is for you. Okay, you can pick and choose. You can literally look at this description. There is one down there which says Llama 3.2 Vision. What do you think that does? Llama 3.2 Vision. If you just look at the description, it will tell you
for computer vision, I think.
Yes, exactly. So it will tell you that if you have a use case where you have to read something that is image, Okay, like you have a picture and you want to extract information about the picture. Let's say you have an Aadhaar card, you have a SSN card or Emirates ID, and you want to extract that Aadhaar card number or something, or Emirates ID, and or you want to just ask a question, explain to me this national ID, and it will be able to tell you that this national ID is an SSN, it contains SSN number and it has certain other information. Or you give it a credit card image and you tell it that, extract the credit card number, what is the CVV number, it will do that. When you have those kind of requirements, the model that you will be using is something like a vision capable model, which can read an image. The one that we are using right now is called Llama 3, and it is capable of reading text only. If I give it an image, it will not be able to read that. Okay. So here, this is a very, very nice and important resource called ullama.com, where you can get information about all the different models available, what are the capabilities, and you can pick and choose the way you want. Rajan, just click on any of those, the top one, maybe Llama 3.1, just click on that. In your list, you're seeing Llama 3.1, click on that. Yeah.
Yes.
You see, more as you go deeper, you'll find more and more information. A lot of information is published about Llama 3 and what it can do, what it is size, what are the different other versions, everything. You can just go through it. Okay. All this is available for you if you want to do research on these models. And yeah, see, tons and tons of information is available here. Now, I want to ask you one more question. Rajan, just go up onto the search bar. Okay. I want to ask, let's say you have a requirement. We said you have a requirement where you have an image. What happens if you have a video? Do you think AI can process that? What will you do? How will you know which one to take? Rajan, put video there.
Video.
Okay. We can't see your
video.
Is it possible to?
Does he need to prompt Vijay? Which Ollama do I need for video?
No, we just have to put that, and it'll give you all the models that are available for that.
Okay.
Do you see the last one? What does it say? I can't read it, but it says neat video or something. The last one in that list, yeah. 1, 2, 3, 4. 1, 2, 3, 4, 5.
Manish Thota lava _next_video.
Yeah. So what this is basically doing is that it is giving you all the models that are available, which are video capable. Okay. So now you can imagine any use case that you have. You just have to come to this interface, put in your requirement, and you will get. There is a very, very good chance, 99% chance, that there will be a model available for you which can do that kind of processing. Okay. You just have to take that model, exact same command that I showed you. You see this command. Rajan, I need you to zoom this. Control plus.
1 minute.
Yeah. Control plus. Yeah. More.
Is it okay?
Do you see this command on the right hand side? Ollama run Llama 3.1. If you open up the other one that he just showed you, that will also have this kind of command in there, the video one. Open up the video, Rajan. Again, search for the video. Yeah, and hit that, Manish Thota.
No, it's coming like this.
Just again do that.
Yeah.
Yeah, there you go, Manish Thota. Open up. Do you see that command at the end? That's a command you have to pick up and run, and that model gets installed. It's so easy. It is so extremely easy for you to get these models and then get started on your use cases. All right. That's the reason this site ullama.com is so very interesting and so very resourceful for all of us.
So where we have to paste this command?
On the command console. Just open up a new command console and just paste it. That it will start downloading and installing.
Like this here.
Exactly. Yeah. Only thing you have to be concerned of is the size it takes, because this text itself, don't close this. Okay. Yeah, this is done. I will go through the size it takes. The text model that you did took about 5 GB. This video model probably will take 10 GB or more. So that's the thing you have to be concerned about. But as far as usage of this goes, it is so easily available to all of us. Okay. Think about it. 10 years ago, 15 years ago, none of this was possible. And now it is so easy for us to get these things and get started with any of our use cases.
So I should say that these are the pre-trained models, and we are using those pre-trained models related to video processing, related to image processing, related to some other database processing, right?
Yes, absolutely. Yes, these are pre-trained models. And the most important thing is whatever we are looking at right now are all free models available. You can, and they're free for you. It's for your at your disposal.
Okay.
Okay. Now, Rajan, go back to your console. Yeah. So I'm assuming others also would have been able to install this, right, up to this point. So Rajan has got it installed. You see, he's got a prompt there. Send a message. Rajan, put there. What is the capital of Germany?
What is the
capital of Germany? Okay. Can anyone tell me what is the correct capital of Germany?
Bonn.
Do you think our AI will be?
France.
Bonn.
So we have Bonn and we have what? France?
Oh no, Paris.
Capital of Germany is Berlin. So what do you think? AI is correct or we are correct?
Berlin.
That's interesting.
Okay, let's try something else. How many planets are there in our solar system?
Oh, I have not a clue.
In our solar system.
Guess a number.
Yeah, guess a number. Let's before that. We want to see if AI is right or we are right. Okay, it says 8. I believe someone would have definitely said 9 because that's a controversial one. Okay, all right. Rajan, just type generate a hello world program in Node.js.
Right?
Remove the dot. It'll still be able to understand, but that's just to make things easy for it. Yeah, go for it. Think about it. Now just think about it. What you have in your hand here. You tell it what you want and it does it for you. It does not matter which area you are in. Science, mathematics, let's keep mathematics aside. Science, history, geography, English, language, movies, whatever you need, this LLM model has it for you. Okay, it's just a matter of you downloading it and knowing how to use it. That's it. And then you have the entire strength and capability and the power in your hand. Okay, this is what AI brings to you. And this is what is happening on your machine. We are not talking to OpenAI, Grok, Anthropic, or any of those guys. We are talking to our own system. This is completely owned by you now on your machine. All right. And congrats, Rajan. You have a fully capable AI system on your machine now.
Yeah, but I'm not capable, so I will do.
Absolutely, you are.
I think it's a very good bridge to take that picture, right?
Yeah.
Shall we do that with?
Yes.
So we check with brief question.
Yeah.
Is Llama is part of Meta, right?
Llama 3 is part of Meta. Yes, correct.
Okay. Yeah. And are they competing, ChatGPT, Llama, and what else? Are they competing?
Yeah.
LLMs?
They are. And I'll tell you a little history behind that, the background. The reason why Meta made their models free. So what happened is there's been a lot of research happening for many, many years. Okay, Google was leading that research. And all of a sudden, Sam Altman came in and said, I have OpenAI GPT models. Okay. And he came up with these models which could do amazing things. And he somehow just stole the whole progress, and the whole world was went for that. He made it paid. He made his models paid. Now Meta from Zuckerberg said, okay, now we are too late for this, because if we also make our models, we also have the capability. We also have absolutely good models. But now if we make paid for it, why will anyone come and subscribe to us? Because GPT already is so famous and everyone wants to use GPT. So what he did is he took an exactly opposite approach. He said, We have an equally capable model, and here it is free for you. The whole world went in that direction. So right now, so that's the reason he made it. Free, open source.
So
to beat the competition.
So let me just be. So somebody said, if something is for free, you are the product. So where's Meta making the money?
Yeah, and Meta has their own way of making their money. They just need people, right? They make them. They'll make. So it's basically like that. They make it free. They make you dependent on it, and then
they introduce
they have their ways of
a small fee. Okay, I know how it goes. Thank you.
Just imagine what would have happened if there was no open source or free resource available.
Yes.
I would have thought twice about using this paid models, and probably I wouldn't have made that much progress in researching AI and using AI for my applications than using the free models, right? So that's the other side of it. So that's where we benefit.
I can see.
We always have a choice. We can go for the paid. We can go for the free. Now, when we have both the choices, we just pick our models, whichever works for us. And that's a huge benefit that we get now.
And it's open source. It's for free. Okay.
Yeah.
Okay, let's take a break and get a picture together.
Yes. So can everyone just come on the camera so that we can take a quick picture?
And yes.
Yeah, Rajan, I think you'll have to stop the sharing so that your no, actually,
it's okay. I can see everything.
Okay.
That's okay.
So can everybody go on screen even without makeup? That's always a concern.
I gave 10 minutes time.
How is my hair?
Everyone's pretty here.
The pictures are small, so we won't see your pajamas.
Nice. Very good. 1, 2, 3, 4. I think we have a few more people.
Yeah.
3, 4, 7 to 9. Yeah, I see 18 participants. I expect some more faces.
Yes, someone please press the button, FaceTime.
You tell us when you're clicking, okay? We have to smile.
Yeah.
Nice.
Perfect.
One more. So maybe a couple of more need some encouragement.
Yes. Yes. One more.
Nice.
Very nice.
Yes.
Very nice.
Oh, you need to allow. Yes.
That's a very interesting feature, which is going to everyone's camera and taking a picture individually, and then it will make it together. So I'm not taking a screenshot. It's
Oh, Abhi was
that I'm
briefly there, but
photo not yet taken. Abhi, Ranjan, and Sudhanshu.
yeah, Abhi was briefly here, but he was, maybe we shocked him. Yes, no.
Yes.
Good to see you.
Thank you.
Yeah, that's good. I think it will do the job. Just bear with me. Just to be safe, I'll also take a regular screenshot. I don't know. Otherwise. Abhi, can you show up one more time?
Yeah.
Yes, perfect. 3, 2, 1. Nice. I got it. Cool.
Great.
All right, cool. So let's circle back. So we were at a point where we have installed the Llama 3 model, and you're free to install any of the models that are available there, whichever you want the capability. So the reason it's important is because these models that are available are not only differ in their capabilities, like one can do text processing, one can do image processing, another can do video processing. They're also different in terms of the size of it. So the processing that we are doing right now is text-based and on our laptops. So Llama 3 works perfectly fine. But imagine if you have a case where you have to do this AI processing on your cell phone, on your mobile phone. That means a device which has limited size, right? Resources. You cannot go with Llama 3. You will have to go with something that's even smaller than Llama 3, like 𝘊3. There's a 𝘊3 model also available on that ollama.com. You will be able to use that, and you'll be able to use that in your mobile devices or any other smaller devices. That's the reason why having this different capabilities of the models become very, very important for you. You can just explore, you can be creative, and then you can utilize this the way you want. All right. So now that we have this Llama 3 and Ollama done, we have just one more step to go just to test our application. We need Python also to be installed. So Rajan, can you bring up your screen and we'll do that installation. And once we do that installation, we'll take a short break and come back then. Okay, let's finish this last step on Python now.
Okay, yeah. So where I have
here, what you can do is you can do a /by, and this screen will go away. This you'll be exiting this /by in your console. By BYE. By BYE by.
BYE.
BYE by, yes. Yeah, that's it. Now you're out. Okay. Yeah, that's fine. Okay. Now, Rajan, actually just start up. Keep that Ollama running. Open up a console.
Okay.
Okay, the command is Ollama run Llama 3. Double L, no, 𝘗𝘭𝘶 𝑚𝑎 3. That's it. Ollama. So you missed a A. Yeah. Okay, so good. So we will have the server, keep the server running. You have the model also active now. Only thing that we are missing now is Python. Okay, you saw that architecture diagram, right? We're taking the request through Python, and Python is then passing it to the LLM server. So let's put Python also now. So Rajan, go to that GitHub instructions again.
Okay, just give me 1 minute. Okay, on which page I need to go?
Machine setup. Go to machine setup. And again for Windows, machine setup for Windows. Okay, so you've done the initial steps. You went all the way to number 2 is done. Number 3 is done. Number 4, let's skip for now because we need Docker for that. Go for 5, straight go for 5. So download Python. So what you can do is just go to Python. Just go to that python.org. Don't take the whole link. Just go to python.org. Just up to python.org. Yeah. Yeah, and put it on your browser, and let's download Python. What is the version it is telling us? Is stable version. Let's do one thing. Put a Python download 3. I'll tell you what to type. 3.13.7. You can just put 3.13.7. It will come. 3.13.7. On Google, in the browser, just put Python download 3.13.7. Right there on the URL, you can put up there on the URL, you can put it. Yeah. Python download 3.13.7. Yeah, pick that. There must be a download link somewhere there. Keep going. Yeah. So you have Windows, right? What is no? Don't click that. This on the right hand, on the left hand side. You see Windows installer 3264. Left panel version. Keep going down.
Here is installer 6432.
Windows installer recommended that you do the 64.
So I need to click on that Windows installer 64.
Yeah, I can't read your screen. Can you just control plus?
Now is it okay?
Yeah, pick that. Yeah, that's the one, and it will download now. Okay, is it downloading already?
I'm clicking on it now.
Yeah, it started. So everyone, are you all on the same step? We need Python. Anyone's having trouble with this? Okay, so yeah, once it's done, just open it. Open that directory. You can open that directory. 1 minute. Very important, everyone. When this screen comes up for Python, you have to hit that add, those two check boxes that are there. You have to check those boxes, okay? Down there at the bottom. Yes. And go for install now.
This one?
Yes, install now. Go for it. Yeah. Let's install and then. If anyone's having trouble, let me know. This will be the last step for installation. We will run a very quick test before we take a break. Setup was successful. All right. So this part, you can close this. Now go back to your GitHub steps. Okay. We are on step number 5. You've done A, B, C. D, E is also done. Open a new command console in E. Open a new command console.
Same. I need to open or
new command console. Okay. Now there's a command in that. Next step to put that command in there. Scroll down at step number 5. 𝗶 version, that one. F, correct. Yep. Go for it. There you go. So your Python is working and you have 3.13.7. Can everyone just tell me if you all are here at this point or anyone's having trouble? So with this, we have Python installed. Okay. All right. Fine, Rajan. Let's go to the next step. Next step is yeah. So now we have that done. Ensure that okay, that Python step is done. 5 is done. Now we will run a program. Okay, we will run a program and see whether all this is working or not. For that, just create a directory on your C drive with that name 𝘗-AI. On your C drive, create a directory with 𝘗-AI as the name. No, you go open up your file explorer, C drive, folder, any folder you open from your Windows.
Like this?
No, from your taskbar, you see that there is a file explorer on the taskbar. Keep going to the left.
Okay.
Yeah, open that and go to C drive. C drive. And create a new directory here with that name 𝘗-AI. And you can maybe make, I can't clearly see your screen. Yeah.
But when I'm creating that folder, so it's showing dash means hyphen cannot become.
Maximize your screen. Maximize your folder, that one which you open. Okay. Now right click.
It's done, I think.
Yeah. So remove that. Is there something like C in there? Remove the C. Only 𝘗-AI is required. Rename it. Okay. So you have 𝘗-AI. Open it up. All right. Now what you have to do is go to the GitHub directory. Go to the GitHub location on the browser.
Okay.
So if anyone's unable to follow, do let me know. We are simply taking a program from the GitHub and putting it in this directory now. Okay.
So
you can go to the GitHub that you opened up on your browser. On your browser. Yeah, here. Do one thing. Just create a duplicate of this tab. Just create a duplicate of this tab. Or let's do one thing. You go one layer up. You see that Bootcamp AI December 2025.
This one, yes.
Go there. Yeah. Okay. Now in code there's a drop down. Drop down. Download zip. Yeah, go to that. Open to that directory. Downloads. Unzip it. Extract all. Okay. Now go inside. Copy. Okay, I can see. Yeah, copy pattern study. There's pattern study there.
Yes.
Copy that and put it in that 𝘗-AI directory. Great. Now go inside. Okay. Yeah. So now go to command prompt in this location to pattern study.
Right?
CD. Yeah, CD. Do CD and name.
Like
in
this.
front at the start, at the very start, small case CD. Remove that. Go all the way to the start. small case cd, small lowercase space. Yeah, go for it. Okay, did. Now, again, go to GitHub. I'll tell you the command to paste here.
Okay.
Okay, pattern study. No, sorry, not pattern study. Machine setup. Machine setup. And Windows. Windows. Next one. Go to that step number 5, I think it was. Yeah, test your AI setup. That's the one you want. And there is a command there. Step number E2, 𝘊 𝑃Y1-ULAMA. That's the one you want. Copy that and let's run it. Yeah. So everyone, we are testing our GenAI setup now. We are going to run a very simple program to test. So have you all reached this point? There's a space in front. Remove that space at the start. Yeah, and hit enter now. Hit enter. Okay, this is fine. Everyone, are you all here at this point? Anyone's having trouble? Do we need to slow down? Okay, all right. So Rajan, this is expected. What you do here is that, again, go back to GitHub. Yeah, so you see the next one, pip install request 5e3. That's the one you want. Yeah. Now go for it. Okay, so it will download whatever is the missing library and it will put in your machine. Now again, type the same command, earlier command, the one that failed.
This one.
Yes. Yeah. Yeah. Enter. Go for it. So let's allow it some time. Okay, so here, now you can maximize this. We need to take a look at this part. So everyone, just take a look at the screen here. So what Rajan has done is he has executed one program, okay, and he has got an output. And Rajan, can you open up that program if on your local machine itself, or yeah, on your directory, you have that program. Just open it up in Notepad.
Where is it?
Pattern study. Pattern study. Yeah, 𝘓-ULAMA, the top one. Open it in Notepad. You can just open up Notepad and drag it to it. There you go, Notepad here. And maximize it. So you see, everyone, take a look at this. This is a very, very simple program. What we are doing is that on line number 4-5, you see that what is the capital of Germany? This is exactly what Rajan had typed on that command console. Remember, what is the capital of Germany? Same exercise we are doing through a program. And the reason we are doing it is because we want to test the flow. We want the request to come in from Python. It goes to the LLM server. From LLM server, it goes back to the LLM. That's the request we are trying to test now with this program. And the question that is being asked is, what is the capital of Germany? When this question is asked, it goes to an AI system, and look at the output that Rajan has got. Rajan, show us the output again. On the console. Yeah. Can anyone just tell me if this output is correct? What is shown in this output? Is it correct?
Yes, that 𝘗𝘭𝘶𝗨 done first.
Yes. Yeah.
This one.
So you see, exact same exercise, whatever he did on the console. Now we have done it programmatically. Okay, because it's not like you're always going to have access to that console, right? So you have to have some program that you can write all your logic in, and then invoke the LLM server, and then you'll get a response. So that's what we have been able to accomplish here. Okay, so with this, what we have done is I'm going to share my screen and just show you what we have accomplished up to this point, and then we'll take a break.
I'm stopping my.
Yeah, I'm sharing my screen now. You can stop. That's fine. Is my screen visible to everyone?
Yes.
Yeah.
Yes.
Okay.
Yes.
Take a look at this. Take a look at this architecture. This is what we started off with, right? This is what we started off with. So we said that there are three components. One is the LLM model, which basically is an artifact which has everything in this, which has the knowledge of everything in the world. You ask it whatever question, it'll give you a correct answer. Then there is an LLM server here, which we have chosen as 𝘠𝘂𝘶, which with that LLM server you can talk to your model. Okay, there is no easy way for you to talk to this LLM model directly. There is no easy way. That's why we are putting an LLM server here. There are many easier and very convenient ways to talk to this LLM server, and that LLM server will convert your request and send it to the LLM, take the response and convert it into English, proper English, and give it back to you. So that's the reason we are using LLM server. So the flow that we have just tested now in that simple program is, we have given it a question, what is the capital of Germany? So that's what we asked in that program. That question went to our Python. Here it is Spring Boot, but it doesn't matter. It's just a Python program. That Python program took that question. It made a connection to this 𝘠𝘂𝘶 server. This 𝘠𝘂𝘶 server is running on your local machine right now. Okay, it made a connection to the LLM server, and this LLM server then took the request and it said, okay, this is the request. I have to get an answer to this request. So what did it do? It said, I have a vector database and I have an LLM model here. What will I do? I have an LLM model and I know that LLM model can answer all these kind of questions. So it went and made a call to this LLM model, and this LLM model took the question, what is the capital of Germany? It was able to understand meaning of each of those words. It understood what means what, is means what, capital means what, and Germany means what. Every single word which we say tokens, in terms of AI we call them tokens, it was able to understand every single word, and also it was able to understand the contextual meaning of each of this word. You see there's a word capital in there. A capital can mean many things to many people. A capital means capital of a country. A capital can also mean how much capital did you put into a business. That means how much money did you put into a business. All right. But our LLM model is able to understand that we are actually asking what is the capital of Germany. That means which is a city in Germany, which is called the capital. And hence it was able to, and then it was able to give you the relevant answer. It did not tell you that you have to put $50,000 into this capital. No, that would be a wrong answer. So it understood the meaning. It understood the meaning of this and was able to give you back that the capital of Germany is Berlin. This particular capability is not available in your traditional application. Okay, and that's why these kind of use cases can be solved. That is, natural language questions that you ask can be solved with an AI system, and they cannot be solved with a traditional system. Okay, so congratulations everyone. You'll have a fully functional generative AI.
Hi, 𝗵𝘳.
So 𝗵𝘳, sorry, can we do this before the break or should we do it after the break? I really try to understand from an architectural view. I got the details, but why do they need to hang together? Or is there another way, or is this just one architecture that you have built? So I'm more on a conceptual level. Why does it run through all of this before it comes out at the end? Sorry, I'm a conceptual thinker.
No, that's a perfectly valid question. This is a very standard architecture. You could build this in multiple different ways. Okay, and you realize that I can remove this LLM server out from here. This section here, I can remove, because the only thing that what I really need is all available here. Okay, why not just hit it directly? Why do we have this additional thing? Very valid question. Yeah, because this guy has everything that I want, but it is very difficult to talk to this person, this LLM model. It is difficult. You see the Python program that we have written, which is say about 10 lines, extremely simple, 10 lines. If you try to remove this LLM server and talk to this LLM model directly, your program is going to be very, very complicated. It's going to be very difficult because you have to encode things in certain way. When the response comes, you have to decode it in certain way. You'll be spending a lot of time on that rather than just asking a question, getting an answer. Right? That's why we have this layer here, which does that work for you. It removes all the complication. You just have
which layer you're pointing to?
LLM server, local LLM server, 𝗏𝗏. Where's my mouse? This 𝗏𝗏.
LLM.
Yes, this LLM will take all the responsibility of converting your request into whatever format this LLM wants, llama 3 wants, and it will take the response and give it back to you. That's why we have this flow like this. Always it goes to LLM server, then it goes to the LLM model.
Okay. So it's a translator and the conduit.
Translation, yes, and that's one of the capabilities. It does many other things. When we come to the point where we talk about database, it does interaction with the database also. Which if we try to interact directly, there'll be a lot more work that we have to put in. But this guy, this LLM server makes things a lot more easier for us. That's why we have that in place.
Okay. Thank you.
Okay. All right.
Yeah, Rakesh from this side.
Yeah.
So can we integrate this your backend server, LLM server, with our normal UI, like web applications?
Absolutely, yes. And we will take a look at some examples when
because whatever query you are writing, it was the prompted was in 𝗏𝗏, right? Somewhere. So there only we were writing that what is the capital of this one, what is these things. But these things I just want to segregate from this part to our normal web application.
Yeah.
In web application, so how can we get that final URL, as this is the local host something, LangChain, 𝗏𝗏?
Correct. You're right. So what we just did is we looked at the very bare bones right now. Correct. We opened up, we set up that 𝗏𝗏 and we typed that what is the capital journey inside 𝗏𝗏. So 𝗏𝗏 gives you that capability. Okay. That's the direct way of talking to your AI system. Open up the console and talk, just like you talk to your Windows when you open up the command console and you can type whatever command you want, right? But it's also it's not so easy for you, right? If you cannot give your command console to your business and say, go and talk to my AI system, right? That's why you will need a UI to do that. That is definitely possible. And we will look at that part also. This program that Rajan just ran is just one step in that direction. So at that program, he did not go to the 𝗏𝗏 console. He just was one level up. He was like at this level here. I'm showing you Spring Boot, but this is where he was. We just had Python. Okay. So that way you have more ability to write a bigger program also. Bigger program, more logic and all that. You don't have to depend on the console now. You will see at the next level that you don't even have to write the Python black screen program. You can launch a web browser, and just like ChatGPT, just like ChatGPT that you're typing on that interface, we will come to that point now, and you will see that we will be able to type this out in the prompt in the text box, hit submit, and then goes through this entire flow. So we will actually be generating something that ChatGPT gives you today. Okay. Yeah, so that's what it is. We did very well. We did up to this point that we actually got the system working on your machine, and we actually tested it out. It works perfectly fine. The flow went all the way from Python all the way to your LLM server, then to your LLM model and back. Okay, so it's all good. It's very nice. Congratulations, everyone. What we'll do is probably take it's 11:20 in India. We'll take a 10-minute break. 11:30, let's come back. And we will then look at some hands-on exercises. Okay, now you will see what the actual working of these programs. All right. So let's take a
Okay.
break. 10 minutes will come back. It's 11:20 here in India. 11:30 will come back. Okay. Thank you.
Okay.
Hello, are you all back?
Yes.
Okay, perfect. Okay, so let's get started then. I'm sharing my screen now. So, okay, tell me once it's visible. Is it visible? Are you able to see?
No.
No. Let's share it again. Now?
I see many. No, yes.
Okay. All right, fine. So what we just looked at in the earlier session is that we established a flow where we could ask, where we put in a request, which was a question, and that question straight away went to an LLM server, and then LLM server interacted with the LLM model. The model was able to understand what the question is, and it was able to give us the right answer to that question, and we got a response back. Okay. What we'll look next is, so I want to ask you a question. So this model is able to answer all our questions, right? The different types of questions that we asked it. You'll all have heard about Agentic AI, right? Can anyone tell me, have you all used Agentic AI? Anyone on the here?
No, I have not used it, but I have written one agent, AI agent, and my study is in progress as of now.
Good. Okay, fine. So you've taken one step forward then. Okay, but tell me one thing. We just said that this LLM model that we have here, yep, it has all the knowledge in the world. Correct? You can ask it any question and you get an answer. What is the capital of France? What is the capital of Germany? What is the how many number of automobile companies are there in this world? Any question like that you ask, you will get an answer. Correct? Then why do we have to have this agentic AI in place? What is the need for that? Pretty much
actually for our customized it means, as what I understood, like we understand agentic AI a kind of agent that how we are interacting with some agent, like execution for particular work. Means it can call multiple services and finally it will take some decision, and finally it delivered whatever I'm expecting, like reservation, railway reservation. So it will optimize, it will search multiple locations, and based on that one, as whatever request I have placed there, based on that one, it will take some smart decision, and finally it will deliver that whatever I'm expecting.
Correct. Yes.
Correct me
So
if I'm
why
wrong.
is it that? Yeah. Go ahead. Someone was talking.
Agentic AI, isn't that some agents work together under the supervision of the James Bond agent, of the supervisor agent?
In that line, yes, on those lines, yes.
Yeah.
And same thing. What I couldn't get the name of the person who spoke, but pretty much on those same lines too. Let's make it a little more specific. Okay, let's make it a little more specific. The question here is, this LLM model that we just saw and we experienced, we got first-hand understanding of how powerful this is, right? It is something that has knowledge of everything. And imagine a person sitting in front of you who has knowledge of everything in this world. Won't you be amazed that this is a powerful person? He can literally do whatever you want him to do. He can answer all your questions, solve so many doubts, solve so many problems and all that. That's what this LLM model is. Okay, it knows everything. But still, we have resorted to this other approach where we are saying we have to use agentic AI. All right. On similar lines to what the person just said, when we have certain things to do, like search for something and all that, we use agentic AI. But why is that LLM can't do it? Is it that LLM can't do it? That's why we are going to agentic AI?
No, LLM can do it, but the thing is that I am specifying a particular agent to do a specific task for that thing. Technically, LLM is capable to do this thing, but I am forcing an agent to do a particular task for that thing.
Okay, very good point. Very good point. Okay. Anyone else has a view on this? So LLM can do it, but we are still using agentic AI to apply this do this work. Anyone else has a view on this?
I don't think agentic AI can do it.
Agentic AI, like a task which requires
like a because it's an interaction of various workflows. It's an interaction of various workflows. They need to be carefully designed in terms of decision rights, in terms of information rights. So there's a lot of architecturing behind. I think a simple LLM cannot do this. That's my take on it. Maybe it's very naive, but yeah.
No, it's a logical one. It's a logical one. Okay. Now, if anyone else has a view, do feel free to talk about it. Okay, whatever your view is and whatever you understand.
Yeah, is the see that even in our agentic AI, we are using LLM only, but we are using for our customized applications. We are going to infect our on our own data, personal data as well. And finally, we are delivering that things. Because here you, as what you in starting, you told me that the fraud detection for bank, you know, that I got confused that how can I expose our banking information to outside of the world? Because you know that most of the banks are not, they are highly secure. They are securing their own data. They are not allowing others that others can find out that what are the frauds are there. So this kind of fraud detection should not be done by others. By only bank only inside their internet application only they can do. So at this moment I was a bit confused. Even still I have more doubt over that one. But as what I notice here that AI means in agentic AI is a kind. I'm just understanding this part like object-oriented programming, how we do, or as an architect. Actually, I'm integration architect. In starting, I was not there in your. I had joined late. So in integration, we are integrating APIs. API, we decide that what are the APIs are available in market, and we optimize that one, and finally we integrate and provide the final endpoint to the application, that whatever application is there, based for our application specific we do. Now, now I'm looking here that in place of API, maybe I will use some multiple agents, and that agent, based on agent only, we will provide some good architecture in a backend, and finally we will deliver one endpoint, maybe a kind of this kind of deliverable I can provide to our company.
Correct. Yes, all valid points, and everyone's been going in the right direction on this. Okay, I want to point you to however powerful this LLM is. Okay, we have seen the power of it. It is like almighty. There is one flaw, one thing that it cannot do. Okay, it does not have that capability of doing it, this LLM. And what is that? It has all the knowledge in the world. Okay, it has all the knowledge in the world. You ask it a question, it'll give you an answer. But it does not, if there is something that it needs to connect to some resource and get that information, an LLM cannot do that. Okay.
It will work on historical data, right?
It will work on, this is a very, very important aspect of an LLM, which we need to understand so that we know the capabilities of it and also know the flip side of it, what it cannot do. Okay. So as engineers, as builders, as AI solution designers, we need to know what is the capability of something, that an AI component. We also need to know what it cannot do. Okay. So I'm going to highlight to you what an LLM cannot do now. An LLM can only answer your question based on what information is fed into it. That's it. Nothing beyond it. All right. So each of these LLMs, when they were created, for example, Llama 3 was created in the year, I believe 2021 or something. They created it, they released it. Whatever they fed into Llama 3 was up to that particular date, up to that particular minute, up to that particular second. All right. Anything that has happened, any information that you're asking this particular model, which it does not have fed, it cannot answer it. Okay. Now, if I ask you, Rakesh, if I ask you, Rakesh, I'm asking you, what is the capital of Germany? What will you say? Capital of Germany is Berlin, right?
Berlin.
Our LLM model will also say that the capital of Germany is Berlin, because this is an information that is fed to it, and that information does not change, correct? Once it's fed, it's there. It normally does not change. It was fed in terms of in 2021. Even now, if you ask what is the capital of Germany in 2025, it will still confidently tell you it is Berlin. Change that question a little bit. I'm asking you, Rakesh, same way like I'm asking this LLM model, what is happening in Germany today? What is happening in Germany today? What do you think the LLM will respond?
No,
we are not asking what is the capital of Germany. We are asking what is happening in Germany today. Yeah. What do you think the LLM will respond?
Well, they will scrap the internet.
No, they will say sorry, okay. I guess.
Okay.
They will
what will you do? Okay. Let's just flip this question a little bit. If I ask you, well, what is happening in Germany today? What will you do to answer that question?
I will go on my news channels or on ChatGPT.
Absolutely. Each one of us would do that, right? We would go to some resource that we know this information is available, connect to Google, connect to some research, some search engine and do that, correct? When we ask our LLM the same thing, what is happening in Germany, what it needs to do is it needs to connect to a resource. That resource could be an internet. That resource could be a database. That resource could be a file system, wherever this information is available. But the bottom line here is an LLM cannot connect to any of the resources. And that's why an LLM is incapable of answering this, solving this problem.
So that's interesting, Vijay. Why cannot they go to the internet?
Yeah, the reason is that an LLM is just an inert artifact. It's a software that is created which is completely inert and does not have the capability of interacting with anyone. It's like your laptop where the internet is removed. If it needs to answer, to solve a problem where it needs to connect to Stack Overflow or encyclopedia or something, will it be able to? It won't, right? It has all the information in your hard disk, but anything beyond that, it needs to connect to internet, and now you pulled out the plug. That's what a LLM is. Once you feed all the information, you pull out all the plugs, and the only thing you have is something that's completely independent and by itself a standalone. That's what an LLM is. That's what we need to understand.
But how do you, my ChatGPT connects me, well, it's a paid version, connects me to sources of the internet?
We will now come to that question. We will come to that, okay? Now we know that an LLM, however capable it is, however powerful it is, there is something it cannot do. That means it cannot connect to anything else. Only thing it can do is answer whatever is fed to it, and up to that point of time, okay? The reason, so it's almost like, you know, even if it has that entire resource in front of it, it cannot do it, okay? It's as good as you, someone handing you a brain, okay, a brain which has full power, full information, everything, But when you ask it a question and it does not have that knowledge, there is an encyclopedia you keep in front of it. It's a book and all the information is available in front of it. It has all the knowledge in the brain, but it does not have the hands to open up that book. If it can open up the book, now it can answer your question. Okay, that's what is agentic AI. You give hands to your LLM so that it can open up the book and read that book, and then thus you answer your question. That's why agentic AI comes into play.
Ah, I see.
All right. So what happened is when they built the LLM, they did all these things, made it so capable. But when it came, as they kept on, as people started using it, they got to know that it can answer all the questions, like what are factual questions in the world, factual public questions. What is the capital of Germany? How many cities are there in the US? How many continents are there? But if you ask it, what is happening in Germany? That is something it cannot answer. The reason is it does not have that information. If it needs to answer that, then there has to be a capability provided to it so that it can connect to something. It can connect to the internet. It can connect to a database. It can connect to a file system, read it and answer it. That is the capability that they gave it next. And that capability is called agentic AI. Okay. And now on, the exercise that we will be doing is we will see how to actually make your AI, how to make your LLM agentic capable. Okay. The fact still remains that your LLM still cannot connect to anything. But what we are doing is that we are giving your AI program an additional resource, an additional library that has the ability when your LLM can tell. Even though LLM cannot connect to an external resource, it can still tell, it can signal that I don't have enough information to answer your question. As soon as it does that, what our program does is, okay, you don't have this information, I will help you out. I will connect to something and provide you that information. Now you take that information and start processing. Okay, this is the capability of agentic AI. Now we will come to that scenario that we just talked about. Rakesh mentioned that when we have to do some kind of research, like we want to do some kind of trip plan, right? I'm saying that I want to go to Dubai. I have 7 days. I want to go to Dubai. Give me a plan. What will happen is that an LLM will have only some information about Dubai, generic information about Dubai, but it needs to have there may be cities or some monuments in Dubai that have been created after after the LLM was created, correct? Because Dubai has a lot of things happening. Burj Khalifa, so many new monuments coming up almost pretty much every few months. That LLM may not have information about these newer ones, correct? Now someone has to connect to the internet, find out which are the monuments that are new, what are the new places of interest and all that stuff, and that. So that is the capability that that agentic AI brings to the LLM, and then that's how we then can answer this question. Okay, so and there is a reason why we call it agentic. Okay, the reason is that what happens is that when the LLM says that I don't know this information, when it signals that, we create specialized resources, and these are called agents. So let's say, for example, you are in a business, and you have a core business, your core business of say finance. But let's say your office, although you have a core business of finance, there are other things that you have to do. You probably have to also get food for the employees, right? And certain activities, housekeeping activities, which is not your core business. But then what you do is you delegate it to someone. And that person you delegate to is an agent who's more focused on that and who is an expert on that. Okay, so these agents that we are talking about are experts in doing a particular task, and that's why this whole approach is called agentic AI. Anything that an LLM cannot do, we hand it over to an agent, and that agent will do that particular task. We will look at certain examples now on how this is done. All right. Now coming back to your specification, when we asked what is happening in France today, our LLM was not able to answer it. Okay, I'm going to show you one example where we are going to ask this question to our agentic AI, and we will see what it answers back to us. Is my screen visible here? Okay, I'm going to ask, run this program here. Okay, just look at this output, and I think I'll just open it up here also in the GitHub. You all have this GitHub program with you. Where is GitHub? Yeah. So I'm in pattern study, and in that there is agentic. I'm going to 𝘂𝘂𝘶, and I'm opening up this program here, which is 26 tools search. Okay, so this is a very simple program. I'll explain what is happening here, but just take a look here. This is the question I'm asking here. What is happening in France? Exact same thing that we were discussing. What's happening in France? And I'm going to execute this program here. This is 26, and I will run 26 and see what is happening. Okay, it started looking, and you see this DuckDuckGo. DuckDuckGo is a search engine, just like Google search. Exactly what you would do when you ask what is happening in France, you would try to reach out to a resource, and that resource would be something like a search engine or something. This is exactly what this program is doing. Okay, it is reaching out to a resource, it is connecting to the internet and putting out the question, they're getting the information. Why? Because the LLM is not able to solve this type of problems. That's why we shift to an approach that's called agentic approach. And with agentic approach, your program, your AI is now able to connect to an external source. Here, we are connecting to the internet. You can as well tell this program to connect to a database, to connect to a file system, to connect to some other resource. You can tell it, and then it will do that, and it will get you the answer. So you see what is happening here. Just look at this part here. We asked the question, what is happening in France? What it did, it started a thinking and planning process. Okay, you're asking me something, I need to answer this question. It first went to the LLM and it asked the LLM, can you answer this question? This is the question I have for you. The LLM tried, and then it signaled to it that I don't think I have enough information to answer this question confidently. As soon as it got that signal that LLM cannot do that, it started invoking its agentic capability. That means it started using its hands to open up a resource, and the resource that it opened up is the internet resource, and it connected to a particular search engine. And this is what it did. You see this? It went to all these websites, msn.com and whatever this thing is, and it got some information from there. It went to also, all these are MSN only, but different resources on MSN. This is what our AI did to solve this problem. Here it went to yahoo.com and some mentioned global.com. It went there and it picked up all this information, and finally it gave you this output. Recent news from France includes a doctor is sentenced to death for poisoning people and all that stuff. Okay, so this is what we did. The problem that we had in hand is could not be answered by a regular AI, regular LLM, and that's why we used a LLM approach. Okay, so it's very important to know which approach to take in what situation.
There's still something missing. That's interesting. You know, and that's for me the interesting bit, where the human in the loop, because I'm I read every day France news.
Mm-hmm.
So
yes,
it's still, even though, so I'm just thinking it's still within boundaries. You still need to check it, don't you?
Yeah, that's absolutely required. Absolutely required. However confident you may be about your AI solution, you have to have a review. Okay. Because AI, if you see, AI, the base of AI, the data science that of AI is based on approximations.
Yeah, yeah.
And if you are doing something to approximation, how can you logically say that you can always be accurate? You cannot.
Yes. Yes.
So that's why you have to always review it. But the effort is being made to create these models in such a way that at least 80-90%, whatever they process, you can be assured that it's right. But let's say you're applying it to something very, very critical like healthcare, finance, then there is no way you can actually rely on it fully. You have to put a very, very strong layer of verification. But something like this is fine, right? What if there are 10 different events happening in France, okay? And I'm asking what is happening in France today, and it gives me 4. doesn't really harm much, right? But imagine if you had to do the same thing with a traditional system, how much of effort you would have to put in place to get this result.
It's still remarkable. I agree with you.
So it's very, very good to use it in this kind of situation. But when you try to use it in something very, very critical, you have to think twice, maybe think more than that, in fact. Okay. Now,
so I saw the tokens you used for this request.
Yeah.
Would you say something at the end about the tokens?
Yes, we will talk about the tokens also.
Okay. Okay.
All right. And there's a very interesting deviation we have taken in this particular program compared to that. I'll talk about that also. All right. The main point here is we have given our AI solution a huge capability now. In addition to this brain that we have, which has huge capability of understanding, of knowledge and understanding. Now we have given it hands also. Okay, so it can reach out to someone else, some other resource, and open up and access that resource. So now we have even quadrupled that particular capability of AI solution. I want to show you how this is working. This is the program. Are you able to see my screen clearly?
Yes.
Yeah. You see, the other program that we had seen, we had literally given it a number of lines of code. And in that lines of code, we had told it, connect to this particular URL and do this. We had literally specified how to accomplish a particular process. Here, what we are doing is an agentic approach. The only thing we are doing is we are putting one block of code here, which is called agent. And we are telling it what I want. That's it. We are only telling it what I want. I'm not telling it how to do it. I'm only telling it, I want to know what is happening in France. You have this particular LLM that you can use, and you have something called DuckDuckGo as a tool. DuckDuckGo is nothing but a search engine, just like Google. DuckDuckGo is just another search engine. When I tell it this, what happens is this agentic process starts putting a plan in place. If you see this here, it will always start thinking and planning. And it will print it out also, thinking and planning. So it starts that process. What it does is that I want to answer this question, that I want to solve this particular problem. What do I have? I have a LLM, which is this one, which I can access. I'm first going to go to my LLM and ask. My LLM says I have all the answers, perfectly fine. It gives the answer back. But if the LLM signals that I don't have, then it says, what do I do next? What can I do next? Then it says there is something called tools you have given me. Okay. Tools is what is the hands that you're giving it. That means it has the ability now to connect to the internet. Not only that, it also has the ability to connect to a specific search engine. I can even put Google search here. I can say DuckDuckGo tools, Google, MSN, whatever those search tools are available, I can put that. And my agentic AI will have the capability of connecting to each of those resources and getting the response from there. This is the massive, massive capability and the uplift that you're bringing to your AI with the help of agentic AI. This is not possible by using just an LLM. Okay, that's where an agentic AI comes into play. All these other things you can ignore for now. This is the most important part. So what you're telling it is that you solve me this problem, which my LLM cannot do by itself. You have the ability to connect to all these external resources, and you can get the answer. So this is how it is written. There is a second part that is also very, very important here, and that the reason why agentic AI is so helpful. You see how simple this program is. Do I really even have to explain this to you? I mean, I don't even have to explain this to you. So ridiculously simple it is. It is just one block of code. I'm creating an agent and I'm telling it, this is your LLM, this is your tool. Go and solve this problem. Give me this answer. And it does the part of thinking, planning, and all that. This is exactly like the agent that we talked of, who's getting the food for you. You have your own business of finance, and you just want food to be brought, a pizza party to be done for your employees. You only have to tell the agent, I want to arrange a pizza party. That's it. The agent will figure out where to get the pizza, how many pizza to get, how to get the discounts, all that stuff, because that agent is an expert in this. This is exactly what this agent does. This agent is an expert in answering questions. It will figure out who to talk to, which internet to connect. Yeah.
Vijay, I have one question.
Yes.
How does the LLM know what is the right time to connect to an agent?
Yeah, so that's a very good question. The point here is LLM does not connect to the agent. Okay. the earlier approach, we were actually directly calling the LLM, and LLM was doing the process, right? Here, we are not calling the LLM directly. There is this agent, is called this agentic framework. There are tools like Agno. Here, in this case, we're using Agno as an agentic framework. Okay. And all these tools and everything that is provided are provided by this agentic framework. So what happens is that when you start this process, this agentic framework takes a stock of what it has first. It says, I have a LLM that I can use. It says that I have a tool that I can use. That means I can use this tool to connect to the internet. Now it says, now the thinking and planning process that I just told you, that gets kicked in. The agentic framework says, I have all these resources available to me. Should I call my LLM first, or should I just go ahead and call the internet? That is what an agentic framework does. If it makes a call to the, if it thinks an LLM can answer this question, it will make a call to the LLM. That decision, the agentic framework takes.
So basically, the decision-making power of agentic AI is that to call an LLM or to call an agent, that decision will be taken by the agent itself.
Yes.
Okay.
Correct.
Thanks. Thanks.
Correct. Yeah. Just like your pizza guy, whom you're telling it, go get me pizza, I have this many people, he will decide whether I should take a bike to go to this pizza place, or should I just make a phone call and get. All the decisions are made by that person, right? That agent, and whatever that agent is. So this agent will do that for you. How to do it. You're only telling it what you want. That's another reason why agentic framework is so very helpful. And that's why a lot of people want to go with agentic approaches. Okay. The planning and everything is done for you by the agentic framework. Okay. That's how this problem is getting solved. The token part, well, here it is. The approach that we've taken here is, see, the earlier approach that we took, where we had connected to Ollama, where we had connected to the Llama model, right? All those are sitting on my machine. Here, what we have done is we are telling you to connect to Gemini. This is another thing I wanted to show you. You don't have to always depend on your local models. Local models are good, but what happens is that when you install the local models on your machine, it takes a lot of space and you need a lot of resources. My 16 GB laptop will not be able to handle a lot of processing work. It'll take a long time. And that's where we also have the ability to connect to external sources. Gemini is one of the models provided by Google. Just like OpenAI provides GPT and Grok provides its own models, Gemini is something provided by Google. And I'm able to connect to that by simply putting one line of code here. Okay. How is all this made so easy for me? All this is made easy for me because there is a framework called Agno that is available. And this Agno has already figured out that if I want to connect to some model, I just have to put this particular model name there. If I want to connect to a particular resource like a search engine, I just have to put this name here. Agno has already provided, ready-made it has given me. I just have to use the right names. That's it. If I want to connect to a database, Agno has already provided me the tools to connect to whatever database I want, be it MongoDB, Postgres, or whatever database. I just have to do an import like this, just the way I'm doing here, import, and just provide that tool here in this list. That's it. Okay. That's another reason why agentic framework is so helpful and why people want to use agentic framework so much. It is extremely easy to solve complex tasks by writing very, very simple piece of code.
But Vijay, you said something really important, and this is the space on my local, let's say, Mac, yeah? Because that is an issue I think you need to really consider before you download. Do I have sufficient space? Yeah? Because you just mentioned Gemini, and that's external, so I don't need capacity to store the LLM, right?
Yeah.
Yeah, I'm on the right path?
Yes, absolutely.
Okay.
Yeah. So you see, there's a big, that's a very important point, because see, when you connect to a resource like Gemini, which is a proprietary resource, you're paying for it. You have a subscription, correct? You have certain quota limits. When you connect to GPT or Anthropic, you're paying for it in terms of money. Okay. But when you have this model installed on a machine, you're not paying for it in money, but you're paying for it in other terms. When you install it, you are first of all utilizing your system, your resources to have that model on your machine. It'll take 10 GB space, 40 GB space, whatever space required, right? And it takes resources. Your CPU is running and all your resources are running. All that is happening on your machine. You're paying in that terms. And thirdly, you're paying in terms of electricity. So that's the cost you're paying when you do it on your machine. And when you do it on the external, the other way you're paying. Okay, it depends on you which approach you want to take. As solution builders, we need to know all the approaches that are available to us. And we need to know the trade-offs between these approaches. That's what we're highlighting here.
And also somebody mentioned earlier, because you work in the banking environment, and I think there's also how do you protect that you don't open all the blacks and the data of the bank goes outside. So that's, I think, is also to consider, isn't it?
Yeah, absolutely. So depending on your scenario, when you know all these capabilities of AI and what can work where and what are the trade-offs, you will be able to make the right decision. If I'm working on something that is so sensitive, like credit card information, let's say I have my customers' transactions, past 1 year's transactions. I want to make a recommendation, a credit card recommendation to him.
Yeah.
I will go through those transactions. I will figure out what is he spending more on. Is he spending more on groceries? Then I give him a cashback card. If he's spending more on travel, I give him a miles card, right? But I have to process that information first, the transactions. If I give these transactions to ChatGPT, that will be a gross violation. I cannot do that. So I will resort to my local system, local setup for that.
Yes. Okay.
Right? Now, but the other way around, let's say Christmas is coming and I am a marketing company. I have to market a particular product and make it available. Will I spend money? On creating a system on a local machine, putting all that GPU and CPU to do that, which will not require after Christmas? Or will I simply use a temporary resource from Gemini or OpenAI and just do that processing and then dispose it when I don't need it? In this second scenario, the second option works much better for me.
Okay.
Right? I just pay for the small subscription, do my processing, do my marketing, and then that's it. I forget about it. This is where you're using either of the solution based on your requirement. So you need to know both options.
So it's no either or. You need to know what's the use case.
Yes, correct.
And
it's always nice to know all the options. Then you have the ability to choose and make the right correct decision. Right?
Thank you.
So and about tokens, so when you make a call to your external source, you are actually everything you're sending tokens, right? Whatever data that you're sending, that is counted in terms of tokens, and each token you're paying for. Okay, the more interaction that happens, the more tokens you're paying for. That applies to all these solutions, all these interactions. Okay, so a couple of points to be taken from here is that Agentic AI is extremely simple to implement. It's just one agent that I'm putting here and just telling it, these are your resources, this is my problem, solve it. It will figure out how to solve it. Okay, it will connect to whatever resource and solve it. All right. And second thing is, what we are doing is we are massively increasing the capability of our AI solution of our LLM by giving it the ability to now connect to multiple systems and process the information. The LLM itself is not connecting. The agentic framework is connecting and giving the information to the LLM. Okay, this is where agentic AI comes into play. Now I want to show you another example. Let's say, let's talk of another problem. Okay, let's say three of you. Okay, say Val, Rakesh, and Rajan. Okay, if I ask you a question, what is the best way to code? Val, what will you say? What is the best way to learn coding?
Vibe coding.
Vibe coding, YouTube, right? One of those things.
Yes, YouTube.
Rakesh, if I ask you what is the best way to code, what will you say?
Yeah, for coding, first we write the use case, and then we start to write the code for that one.
Correct.
Means based on decisions, like coding, as what we say that we have to take some decisions based on many things. So
Okay.
All things will come around this one, arithmetical
Correct,
and
yes.
logical operations.
Correct. So basically what we're saying is there are different ways to learn coding, right? Well,
Yeah.
might think that going to YouTube and vibe coding is one of the best ways to learn coding. You
Yeah.
may think that writing it more technical basics, that will be best. If I ask, say, someone else, Sudhanshu, he might say that go and open up a book, a manual, read that, and that is the best way to learn coding, correct? Everyone has a different approach here. If I tell you to solve this program, if I tell a system, an AI system to solve this program, what is the best way to code? How do you think that will be solved? If I tell, if I want,
what is the question? Sorry.
Yeah, I'll just run one thing and then we'll get back to that. I'll run one program here. 25. I'll execute this program and then we will come to it. 25 Agno. So you see what we are. So we looked at one problem here where we asked our AI, what is happening in France, and we were able to create one agent and we are able to solve that problem. Correct. Now the problem that I'm talking about is I'm asking what is the best way to learn coding. Okay. If I ask Val, you're going to tell me one way. If I ask Sudhanshu another way and someone else another way, right? So what needs to happen is that each of you need to tell your ways. We need to then discuss it and we need to come to consensus saying that, yeah, I think your point is right. This one point is right. Your this point is right. And third one, your that point is right. Now we need to come to a consensus and come with a answer, right? That's how we would do in real life. If let's say you have to simulate that kind of situation in your programming, in your automation, how will you do it? In a traditional system, you cannot do this kind of thing. But in an AI, just like we created an agent, you can create more than one agents. Okay, you can create one agent that can represent Val. You can create another one that is Sudhanshu, and third one that is Rakesh, and you can have these three collaborate and talk to each other. That is another capability that Agentic AI brings to the table. I ran this program here. I just want you to see the output. Yeah. Basically, what I asked is that what is the best way to learn coding? Here, what is the best way to learn coding? Looks like, yeah. So what happened is that it actually started, and I'm only telling it what I want. I'm not telling it how to do. But now what it did is that it went, it basically went to multiple of the resources, some of these resources like PC, Mag and all that, and it tried to find out what is the best way to learn coding. Okay, this is what it did first. And all these resources it went to. And then what it did is it picked up all these different ways of coding. And it's like you three people talking, each one giving a different approach. This is what it did first. It took all these different approaches to learn coding. Now it has to find what is the best way to learn coding. That means it has to make sense of all these different approaches, remove things which don't make sense, and put those very, very important and main points. And finally, it has come up with this collaborative answer, which says that the best way to learn coding is by means of consensus. It has come to this point and said a structured way, a project learning way, consistent way, and this way. You see, what has happened is that we have literally simulated a real life situation. Exactly what you would be doing to solve this problem is simulated here with AI. Okay, that's another application of Agentic AI. So what we did now is that instead of creating one agent, we have created three agents. And what we did is that we told these three agents to collaborate. Do you see this screen here? Do you see this program that I'm showing?
Yeah.
What we told is that you are three agents and you will collaborate. And when we say you will collaborate, what our agentic framework does is it goes ahead and finds, okay, what do I have? I have three agents provided to me. Okay, that means I'm going to ask that same question to each of these agents. Each one will come up with a different answer, and you can give it a persona also to these agents. You can say that you are a business manager, you are a scientist, you are a mechanic. Okay, each one has a different way of learning and different perspective, right? Each of these agents will come up with different approaches. And when you say collaborate here like this, and with agentic AI, you have the ability to form a team also. Earlier we just had one agent, and we can do that also, but in this case you need a team to talk, to interact, to discuss. That's where you have this capability of putting this team together and collaborating.
Yeah, I have one question in this.
Yes.
Like, suppose one agent is telling in your banking system, one agent is telling that, okay, this is the person, he should be given an eligibility of the card with the shopping one. This is the same person. The second agent is telling that, okay, this is the same person, but he should be given an eligibility for petrol card. Okay. The third agent is telling that, okay, this is the same person and his eligibility is more on the movie part. Now there is a contradiction between all the three agents. Okay. So would the probability score will come into the picture, or how the agent will be deciding the thing? Because now collaboration cannot happen, because some agent is telling something, some agent is telling something, some agent is telling something. So the final outcome will be on the log of probabilities, or what?
Yes. So first thing we have to first address is that why is that contradiction coming into play, correct? We don't want that contradiction to come into. We are here to solve the problem, right? So we need to first create a system that can actually collaborate and solve the problem. The reason that contradiction is coming into play is because when you're creating the agent, you are probably creating the agent in a way that's not very ideal. Okay, you can tell it that use this particular model, and you can tell it the particular resource, and you can also give it a very detailed description, just like I've given here, on how to solve the problem. Okay, you can literally tell him that this is the problem we are trying to solve. Do not make a suggestion that is on certain time. You can exclude this thing also, the possibilities also. All that is completely in your control. How you want to control this AI? Okay. If you know that there is going to be a contradiction and this thing, you can literally say that keep these points aside. Okay. Only these people are eligible for getting this particular discount or whatever, and all that you can do. And once you do that, once you give it this elaborate instruction, your AI will then be able to collaborate much more better.
Okay, got it.
Okay. Got it. So this is completely in your control here. Now, what we are also highlighting here is that earlier we had created one agent. Now we have created two agents. If I have 5 people discussing this problem of this thing, the one that we're talking about, what is the best way to learn coding? What do you think? Is that possible? Instead of 3, 5 people?
Yeah, we can integrate multiple agents.
Absolutely, yes. And see how simple it is to do it. Right? You put 2 agents. What will I do here? I'll put agent 3, agent 4, agent 5. And what will I do then? Here I'll come, and in the members, I'll put 2, 3, 4, 5. I can put 10 also. Right? So how easy it is to extend your system. Correct? And you can even give each of them your personas, whatever you want, and you can have that. So that's another reason why Agentic AI is so helpful. It is so easy to implement it. And again, it does a lot of thinking and planning by itself. You don't have to do it. You just tell it what to do. Okay. I want to extend this particular scenario to something more practical. All right. You all are in software field. Let's say there is a requirement that comes in, and the requirement is such that that you are working on a new project, and the project is about creating a new payment system for Swift. All right. What do? We first have a business analyst come up with the requirement. Correct. He'll jot down the requirement. Then a programmer will take that. He will code for it, and the QA will do what? Testing for it. This is how that normally happens. Correct. If you have to automate this, what will you do? the same platform that you've created, instead of this agent, generic agent, you are going to basically put an agent that will say you are a business analyst. Okay. There'll be a second agent you will create. You'll say you are a programmer, expert in Java or whatever. And third one, you are a QA who will be testing this requirement. Okay. So once you do that, you can put all those three here in one team, and you can say collaborate. What will happen is that in real life also, when your business analyst comes with a requirement, it never happens that the first pass of the requirement always passes. The programmer will always have questions on the requirement. He'll go back to the business analyst. Business analyst will then correct, revise and all that, and then send it back, correct? When the programmer then does his coding, he'll send it to the QA. QA will never pass it in the first instance. They will send bugs back to the programmer. They will interact. The QA will have questions to the BA. The BA will then answer those questions, right? There is a lot of real collaboration that happens in real life. This is a fact, and that exact behavior can be simulated with this agentic approach by simply creating those personas. In this case, we're creating very specific personas. You are a programmer, you are a BA, you are a QA. Go ahead and collaborate. And what do you want to collaborate on is what you specify here. You have a project, you have a requirement related to Swift payment system, and you have to come up with the requirement. So what will happen is that the BA will say that, okay, I have to create requirement. I have to create a detailed requirement of how to implement a Swift system. The BA may not know how a Swift system works, and that's why in this agent you will also be providing a tool. That means this BA will be able to connect to the internet, will be able to figure out what is a Swift system, how have people implemented it in the past, what are the main requirements. Okay, this is how an agentic system will work. So imagine how flexible it is and how powerful it is, right? You can simulate any type of situation, and the agentic framework will be able to figure out how to do it. You just have to tell it what you want it to do. Okay, any questions you'll have on this? I'll show you that example, the example of QA business analyst. You see here what I'm telling you in the instruction. This is completely new control. Okay, so in the instruction, you're basically telling that you're a business analyst, create an elaborate requirement for some form, some registration form, capture and all that. You are a programmer, you will write a program in JavaScript. You're a QA, you will thoroughly test the program. All this is in your control. You can give as detailed as possible. The part that happens next is that you're creating an agent who is a business analyst. You're telling him you have access to Gemini. You can ask questions to Gemini. If you don't get enough answers, you can go and connect to your tool. You can connect to the internet and get the answers. Then second one is you're a programmer agent. You're an expert programmer. You can again use Gemini. You can give anything here. Gemini, Llama 3, GPT, whatever you think is the best model to solve. Maybe there are better models for coding, like 𝘗𝘁, 𝘗𝘭𝘶. Instead of Gemini, you can give 𝘗𝘁 here. Okay, that's completely in your control. And then you can, if you want to connect to Stack Overflow or one of these sites, you can go to 𝘗𝘭𝘗 and connect.
So Vijay, my question is, in an organization, suppose if you take a hospital organization, okay. So one organization is the nursing organization, one organization is the floor manager, one organization is the doctor, one organization is this, one organization is that. So you are creating an agent for that thing, okay. But the thing is that right now you are taking the model to a particular model, the Gemini model or any model, okay. So if that organization has its own internal model for doctors, for nurses, so that agent will be contacting the internal model and will be giving the answer, right?
You can, whatever model you can specify here. If there is already a model available which is capable of doing that specific work, it has information about that particular nursing department, you can just specify that here.
So there is no need to go to Gemini model, or you can have your internal model, like a company organization has a costing model. Why it will go to Gemini? Costing model is the internal model. So
you just have to put your internal model name here. That's it. So that's why agentic frameworks are so flexible. There's no restriction here. You can put that model name here, and it'll interact with that model. Okay, so this is completely in your control. I want to ask you one question. Okay, so see, with this approach here, the business analyst, the QA, the programmer, all these will interact. Okay, and they will come up finally with a solution where the business analyst would have revised the requirement 2-3 times, given it to the programmer. Programmer would have written the program 2-3 times, given it to QA. QA would have found 2-3 bugs, send it back. After all this collaboration, they would have finally come up with a finalized version of that particular output. Like BA will come up with a finalized version of requirements. Programmer will come up with a very refined program with no bugs. And QA will finally, of course, do a testing and say pass, correct? So this is what will be the output of this particular collaboration. Now tell me one thing, if you decide that in addition to these, there is also a security analyst who needs to be part of this collaboration, what will you do?
We will create an agent for security analyst also.
Exactly. Yeah. So you are just going to copy this, paste it here, and say that this is a security analyst. And in the persona of the security analyst, just like I'm saying, you are a programmer, you are expert in JavaScript. You will say you are a security analyst. You are expert in CVE or Bob suite and stuff like that. That's it.
Yes. Yes.
Okay. And when you do this, when you put all these members together and say collaborate, this whole process of how they should collaborate, how many times they should collaborate, when they should stop, all this is done by the agentic framework. You don't have to figure out that. The agentic framework will take care of it. That's the reason why agentic frameworks are so very powerful and so very
technically speaking, if I have a system in which there's a miscellaneous software which is coming up or some malware coming up, so you define that particular agent that this is the action you have to take. This is the action on this type of malware you have to take. This is the vulnerability action you have to take. Now, if there is a new vulnerability, then you have to define that agent only part, right?
Yeah. So what will happen is that with the agent, you're also telling it which model to use, right? So when I create a security analyst here, I will tell it this is the model to use. Now I can either put a generic model which has general information about whatever OWASP top 10, top 50 is, or I can provide it a very specific model which I know is very, very specific to my requirement, or I know that it even has a newer, the latest ones. I can provide that also. So accordingly, it will analyze that.
Thanks, Vijay.
That's in your control. Okay. So imagine now, security analyst one thing. What about performance tester? Just add one more agent, performance tester. There is no limit here. Limit is only your creativity. Okay. Whatever is your regular real world situation can be mimicked, can be actually simulated here, and you will get answers which are actually real. This program, when I run, I will actually get a JavaScript program which will do the entire registration form. I will have the QA who will be writing the test scripts which will be tested against that particular form. Okay. You can run this at a later point.
Is that a final agent can restrict someone, like agent team can take some decision over the restriction over something?
Everything is possible. It's in your control. Whatever you put here in these instructions, it will do.
Okay.
Whatever you want, you put in the instruction, and that onus is on you. You have to put logical instructions here. Okay.
Yeah.
If you put an instruction and then contradict it, obviously this is not going to work, right? It's going to behave erratically then. This is in your control and your responsibility also to make sure that this is logical and structured properly. Everything else it will do. Okay. So what you're doing is you're telling it what to do.
Yeah,
and very
so if suppose
do.
one agent is simply intimating me that this thing should be wrong. So based on that output, that agent's output, the final agent owner, agent team, as whatever you have written, there that final decision can be taken care here or not?
Yeah. Yes, it will be taken care of. So that whole collaboration, that whole consensus will be taken care of by this particular agentic framework, specifically talking about this particular team. It's like almost like, you have three people, like QA, this, and then you always have a manager, right, in your organization. If there is a conflict between the QA and the programmer, QA is saying this is a bug, programmer is saying it's not. Someone has to say, right, whether it's not. So that manager will do that. So this person here, discussion team guy, will do that part. It will be handled with the collaborate part.
Okay.
All right. So any questions you'll have on this? Yeah. So now what we will do is that, it's already 12:32. I want to run one last program and just show you. Okay. So this program here, what it does is, this program here is a travel planner. Okay. So let's say you have a requirement. Let's say Rakesh wants to travel to Dubai. Okay. But he has only 3 days or 5 days, and there are many places to be covered in Dubai. He wants someone to create a plan for him. What will he do in real life? He will go to some kind of a plan agency, right? And that agency will say, this is my requirement. That's it. He'll say, this is my requirement. You figure it out. Correct? This is exactly what this agentic program will do. Okay. I'm telling it, just ignore this part here. I've already provided the keys. So I'm just going to enter something random. Okay, so basically what I'm telling it is that I want to travel somewhere and so many days. I want my AI to figure out a plan that is actually makes sense. Okay, if I say 7 days and I have so many destinations to cover, it will do that. But if I say 3 days, then it has to lower the number of destinations, right? I cannot cover in 3 days what I can cover in 7. So that kind of intelligence, that kind of collaboration is what we are looking for in this. Okay, so even if you go in real life, you will always find, you will see that there will be someone who will be taking your requirements. He'll do some research. If you're going to Dubai, he'll find out, okay, these are the main places, these are all the points of interest in Dubai. Like say there are 15 of such. Okay, but someone has to do the planning also. Are you going to go to Burj Khalifa on the first day, or you're going to go on the last day? Maybe your hotel is located close to Burj Khalifa. That's why you want to go there on the first day itself. Okay, you have only 3 days in your trip. Are you really able to complete the Dubai global village? Because it takes a whole day to do it. That's why that cannot be put in your plan. So someone has to do the planning. Someone has to do the research. That means find all the list. Someone has to do the planning where they have to say that from this 15, I think you can do only 3, and this is the sequence you will be doing, right? That particular. This is exactly where our agentic approaches also can have. You can have one agent. I'm going to put in here Dubai. Okay, you can have one agent who can say that, okay, this is your requirement. These are all the things available for you. Okay, he will not say Sydney, this thing, because Sydney does not fall in whatever that Taj Mahal. It will not say Taj Mahal because Taj Mahal does not fall in Dubai. So Taj Mahal will not be included in the list of this thing. It will only include the ones which are actually valid. But from that valid also, you have to figure out how many you can actually make happen, right? That is the planner. So there are 2 agents here that will come into play. One is the one who will do research. Second one is the planner. Oh, too many requests. Okay, so this is where the token thing comes up. It got too many requests and hence denied. We'll see if it allows us. No, it will not allow.
After 2 to 3 hit, normally it works.
Yeah, otherwise I need to have a paid this thing, and then so we'll just give it some more time. But I think I had run this before. Yeah, you see this same request had run earlier.
Yeah.
I'm saying, where do you want to go, Dubai, and how many days do we have to travel? 7. And look at this list that it is created. Thank you for providing information. However, based on the results you have said, I was unable to retrieve as my travel plans never to provide. Okay, fine. This also it did not give me a proper one, but I think it's all because of the tokens.
Yeah.
it's not going to work at this point of time. We'll need to give it some more time. But the whole point here is that I'll show up the program here so that you can understand how this is implemented. And this will be the last one we look at, and then we'll yeah, this travel agent is the one. You see, what I've done is that, you see that pretty much no matter what the situation is, your approach remains the same. Okay. In this case, I know that there are two people I need. So I have created one to represent those two people. I have created one agent as a researcher agent. Okay. I'm telling him search all the travel destination and activities. He'll only create a full list. His main task is just going to create a full list of that location that you're asking for. And here you can give however detailed you want. Okay. It has to be only this, it has to be only that kind of stuff. Or let's say you're a bachelor, you can say, I want only party type places. You can give all that thing, all the requirements here. Then there is a planner. Okay. The planner does the planning part. You'll say you will get the list of destinations. You have to plan based on the requirement of the user. If he says 3 days, then out of the 10 items that you have, you will figure out how many can be accommodated. And that's what happens here. So these are the two agents here, and each of these agents will do, and you can execute that. Then this gets executed. We get the final output. Okay. So the reason it has this other things is because we are using a UI here, and that UI has a certain code. That's the reason it's showing the other code in there. Okay. So you see what we did. If we solved so many problems, and depending on what your situation is, if you need just one agent, one person to solve the problem, you create one agent. If you think you need two people to collaborate and talk, then you put 2. If you think you need 5, you can put 5, and you can ask them to collaborate. Not only collaborate, you may have situations where you may want them to do a sequential task. Okay, one person finishes, then the second person starts. Like say loan processing. In loan processing, what happens? You first get the application letter, right? There's one person who reads the application letter, extracts all the information from the loan, like what type of loan you want, how much loan are you asking for, what is your name, what is your ID card, and all that stuff. The second person will take that information, and then he will say, is this information matching your supporting document? Correct. So it's a sequential process. One finished, second. It's not like collaboration. So in that case, instead of saying collaborate, you will simply say sequential. Okay. All this flexibility is made available to you by your Agentic AI, and that's why Agentic AI. Now you know when to use LLM, and you know when you to use Agentic AI. Okay. With that, we'll conclude this session. But if you have any questions, feel free to ask. If you have to drop, feel free to drop. We're done with the session here. All right.
So this kind of integration we can do in our Agentic AI, like parallel or collaboration.
Yes. You just have to specify the flag there. Just I showed you collaborate there, right? There is an equivalent flag called sequential. It will do sequential. That means first agent will do, second agent, third. It will not come back. Like in the QA example, QA programmer, they will always come back and talk to each other. But here they will not talk. The first guy finishes, goes to the second. Second guy finishes, goes to the third. That's it. That's the end of the process. You can specify that.
Okay. Okay, thank you, Vijay.
Yeah. So with that,
so normally, actually, I have done in 𝘗�ㄵ𝘁. 𝘗𝘗 is a browser, na? There only I simply checked. Means I didn't notice like how can I integrate with our existing services, integrate existing application. So these things still I have gap. I need to figure out like how I have to do. But anyway, my miss. I'm learning continuously. I'm learning. by you kind of good people.
Thanks. Yeah. So whole point here for this bootcamp session was that to give you a real feel of what actually happens on the ground, and how we make decisions based on the capabilities of AI and the AI solutions here, right? And now you've seen how we apply different strategies to different scenarios, how agentic AI can be applied in all these different scenarios, how an LLM can be applied in different scenarios. Okay, so with that, the session is done. Prabhat, are you still here? We are done with the session.
Yes, Vijay. Thank you very much. It was very insightful.
Yes. And just to let the team know, we regularly conduct these sessions to help everyone out here. And we have dedicated sessions. You can reach out to Prabhat, AIforAll Global, for any information or any help on AI that you may need in the future. Okay. Yeah. With that, thank you very much.
Okay.
Thank you.
Thank you, everyone. Bye-bye.
Thank you.
Thank you. Bye.
Yeah, good night.
Good night.